let's see if this works. Awesome. It says that I'm live. Alright, cool. Now if I refresh... There we go, it's live. Alright, cool. So this works now? Cool. Let me just get the hang of this. Let's see if this works. Awesome. Alright, it says that I'm live. Right? Okay, yeah, I believe it. I'm live. So... what am I gonna do about this? Well... yeah, first of all, I'm going to go make a channel in the Discord. Notify everyone. Nope. Alright. And then I'm going to want to do this. You know, I don't want to do a live channel. I don't feel like it. It's not my thing. Alright. Okay, now that I've got all of my garbage sorted out. I think I'm gonna go ahead and actually just start. So, I have a lot of things I need to do with this engine. And I'm just going to go into them. So first of all, what I got working earlier was an image atlas. Now, what that essentially means is that if I go to this folder, pixels, and then where is it? Debug? Yeah, there we go. Okay, so we got our assets here. And then inside the assets, we're basically scanning all of the assets in to the game automatically. And in the textures folder, you know, we have a bunch of textures, obviously. Now, this bear, actually, you can see that a lot of these PNGs are made up of smaller sections or sprites that we want to render to the game view. Now, I don't want to render this entire image, I only want to render parts of it, because it turns out that that's how we make animations, and we want to put all of it into the same image just for organization purposes, just so we don't have a huge amount of stuff going on, because it turns out that when you have a million image files for the player, it's really unorganized. So what I did last time was I went and I made a system for that. So here I'm importing the bear PNG, and if I go here, this is the bear. You can see him, he's cute, you know, he's doing his thing. And then the thing that I got working was I was able to add regions to the image. And then what do those regions do? Well, it basically says there's one, let me zoom in better. So there's one image there, there's another image there, and there's another image there. So there are three inner images on this sprite sheet, and so we need to define where those are so the game can render them. So here I'm saying that there are three of them, and that's how I'm putting them together. So that's pretty much what I was able to do. Now, how you actually switch between those images, let me actually make an example for this so I can show you guys how this works. Then we're going to do P1. Not There we go. So that's going to be key number 1 on my keyboard. And why I'm going to do that is I'm going to, what is it? Current image, or selected sub-image. There we go, equals 0. So this selected sub-image variable basically says whatever, it tells you what image region to select, essentially. And here I need to set value. Now I'm going to make an equals operator eventually for that, but for now I just have to do set value. And I need to duplicate that. So 0, 1, and 2, those are the indices for these image regions that we created. And then I'm going to bind that to the 1, 2, and 3 keys, just so that I can show you this working. Alright. And I'm going to build the game, and here we go, the game's being built. You know what, I'm going to disable this debug, because it's not very helpful. Where is that even coming from? I think that's coming from Image Atlas somewhere. Yeah, see, it's debugging the region, because I had to mess with this earlier to fix some issues. So here you can see we have the game window. You can move around with the arrow keys, and then what I was able to do, and if I could actually zoom in. Actually, here's what I'm going to do. I'm going to do a window capture. Add a window capture. There we go. So that right there is the game. You can see we have the game working. I'm actually going to disable, or no, I'm going to keep the mouse cursor. So here we have, just a super simple scene, pretty much nothing going on. This is just a test. And, we have this image rendering. We can move the image around. Great, whatever. But we can also switch between these 3 different sub-images. And, we can eventually make that into an animation with code. We can automate the process of making that into an animation. But the point is that we can select between our different sub-regions, and that's great. So that's one part of the equation done. So, that works. But that's not the whole thing. So we got it working, right? We got image regions working. The only problem is that we don't want to set all of these image regions in the code every single time that we do this. That's a really inefficient way of doing it. So what I would like to do instead is, have a text file of some sort where I'm like, okay, this is the image metadata, var.png.meta, and then inside of here we would say, oh, there's a region from this coordinate to this coordinate, the region position is here, and then the region size is there, and then the da-da-da-da-da, do that for all the regions, and we're good, right? Or put in some sort of automatic slicing algorithm, because in Unity Engine, what happens is you can have a slice where you basically say, oh, I don't know. So you take a specific size and then you tile it. So you can see that this bear is actually the same size on all 3 of the regions. So you can just move the position automatically. And you can just say, oh, the regions are this big, make them automatically. And I plan to have that functionality as well, because that would make it even easier to set it up, because you wouldn't have to individually say, there's a bear here, there's a bear here, there's a bear here. You can just say, oh, this is how you find a bear. You say, oh, this is the size of a bear. You start at the top left corner and you just do that, and the program will do it. And that's kind of the idea of what I want to get working today. So now that I've got done with my rant, I want to see if anyone has anything in the chat. Nope. Cool. Alright, so actually getting this working is going to be very difficult, because I have to use JSON, and I've not used JSON in a while, so this is going to be pretty difficult. But if I can get it working, then it will be a lot easier. So this is just going to be our JSON variable, and we're just going to put a JSON inside of here. Now the only thing is that I have to figure out how to do a multi-line string, because It's been a while. Is it backticks? No, it's not backticks. Is it 3? No, it's not. That's weird. Now I have to look up how to do C++ multi-line strings. Let's see, how do you do it? Okay, so you straight up can't. Never mind. Alright, well that's pretty inconvenient. I didn't remember it being that annoying. There we go. So we'll just do this. But I can read it in from a file. Yeah, you can tell that this is annoying. How do you do this in here again? This text is pretty long, but will be concatenated in just a single string. Oh, that's how you do that. Wait. So if I do... There we go. That works. Okay. So I can do that. There we go. Alright, well, I'm going to have these annoying... This is a little bit more annoying than most programming languages, what you have to do for multi-line strings, but we should be able to write some JSON in here and have it work out. So I already imported CPP JSON. So let's see here. Let me see what NuGet packages I have installed, because I'm pretty sure I already installed. Okay, so I have Allegro, which, you know, that's what the entire engine is built on, so of course we're gonna have that. Oh, I was watching myself live. Awesome. JSON CPP. Yeah, so what I need to do is I need to figure out how to use this library. So I'm gonna go here, JSON CPP, and just look up a starter video for it, because why not? Did I already watch anything on this? No, but let's figure it out. Okay, cool. So that's... I think I've watched... This was the video I was going to watch when I was doing this earlier. So you can do... Okay, so that's how JSON is written. So you do that. JSON quick guide tutorials point. Let's figure it out. Okay, book. Okay, so that looks like it's an entire object, and then inside of here you've got smaller object. Store information based on their token edition. Below is a simple example. Okay, data is represented in name value pairs. Cool. Curly braces hold objects, and each name is followed by a colon. The name value pairs are separated by comma. Okay. Square brackets hold arrays, and values are separated by comma. Okay. That's good to know. That's important, because I did not know how this whole thing worked. Type and description. Okay, so these are the data types that I can use. Number, string, boolean, array, value, object, white space. No, empty. Okay. That's good. Alright. So, I need to figure out what the structure of this JSON is going to be. Let me just look at this example and think about it. So, here's the variables that we're going to need. And I wish I could zoom in on this. You know, I'm going to do this in here. What file am I going to do this in? I'm just going to close this. I don't need window, I don't need action, I don't need any of this. Let me just remove all this garbage. And then let me make a comment at the bottom of the file so that we can actually get our thoughts together about what we're about to do. So, for the JSON, we are going to need probably these variables, or these are the different types of images that we can have. we can have a regular image. And that regular image, we don't change anything about it. We don't do any weird imports to it. It's just a regular old image that we're gonna do. So, do nothing. It doesn't even need a metadata file because there's no information describing it that we need to give it for anything. So, for regular image, it's pretty easy. For sprite sheet, we are going to need metadata file. And we're going to need to contain regions, way to add regions programmatically. So, you know, what I was saying earlier. And how we're going to do this is we're going to say, oh, you need to have spacing between blocks, specify size of blocks, and then you need to specify offset. And if you want an example of this in action, I would pretty much just go look up a tutorial for how Unity imports images, because I'm going to pretty much be doing that, but in a little bit less user-friendly way, because I don't have the time to make a GUI for this, so I'm just going to be doing this via JSON, which is what I already said, but that's kind of a little bit more into the explanation. So that's one way of generating them programmatically. Add word to dictionary, because I spelled that correctly. I'll do that, why not? No, I'll add this to dictionary. There we go. Alright, awesome. So, that's how we're going to define them programmatically, is we just have those three variables in a JSON object, and that's pretty much all we need to do. The next thing that's up is we need to specify them manually. So for example, let's say that we have a sprite sheet where you can see how it's laid out like this, right? Where it's like perfectly good, right? You know, it's straight, they're all within their own size. The size is the same for every image within the sprite sheet. That's easy. We can just make a program to loop through that. You can't really do that with all of the images, so we need a way to manually slice them. Oh, wait, we need to specify the pivot. Crap, wait. Do we even need pivot for this? I don't even know how you do pivot. Pivot, maybe? Because I don't actually know how you would do that in Allegro, because I haven't even seen anything about image pivots in Allegro, so, you know, I'll just have to see what the deal with that is, I guess. But for right now, image pivots, well, you know what, I may as well look it up. Allegro image pivot, because I haven't actually checked this out. Allegro C++ image pivot. Pivot sprite. Okay. How do we do this? Bitmap, sprite. Like rotate sprite, but it aligns the point given by a specific thing, then rotates around this point. Okay. So for rotation, this is more important. But for what we're doing, I don't think it's that important. So, because I don't think we're going to be doing very much rotation. This doesn't even seem like it would be that hard to add in the future. Because I'm trying to think, would this screw me over in the future if I didn't have it? The answer is probably not, so I'm not going to worry about it. I'm going to delete that. We also just need to, well, block slicing. So that's just block slicing there. That's where we have a grid of images that we can do easily. What if we don't have a grid of images that we can do easily and they're like all random all over the place? Like, you know, maybe there's one here, maybe there's one here, maybe there's one in between, maybe there's one up here. Maybe it's just completely random like that and we have no way of knowing. So if someone were to do that, then we should probably have something for that, maybe. It would be nice to support it, so I at least need to outline it here in case I plan on adding it. So alright, so here with block slicing, or I don't know, someone DM me on Discord, sorry about that. Anyways, let me get back to focusing on this. So thing is that with this we can just pretty much specify a flag to use an algorithm to do it completely automatically. That's one way we could do it, or we could just have you do it manually, because right now all of the sprites that we have are like, they're not really done this way. Well, we don't need this because we don't really have any sprites that are complex enough to need this functionality right now. I don't know about the future, but right now we don't have anything that would need to do this. So we could have a thing to detect regions automatically, but I don't know if we're going to do that. That's an option though. And then a way to specify regions manually, basically do this. So we have an array, or we have an object here, we have an array which, based on the JSON quick guide here, we're just going to call this regions, and then inside of here we're going to do an object, and then the object inside of here is going to be a what is this? We're gonna need, for a region up here, we need, and let me go to definition, we're basically storing two vector 2ints. So there's bottom and top, and I'm actually gonna change the way that I do this. Actually, let me do this right now. Union. Alright, cool, I'm unioning struct. There we go, that. And the reason why I'm doing this is because it's not, a region doesn't only store bottom and top, it stores position and size is another way of doing it. And declared implicitly cannot be referenced as a deleted function. That's weird. Why would adding a union here do that? Okay. It's something about the destructor, which removes all the data. I wonder why the function would get deleted out of nowhere. That doesn't really make a lot of sense. Well, okay, that fixed it. But anyways, point is that a region can have a bottom and top position, and that would probably be used for physics, more or less. And then it also has a position and size, and our position and size is going to be what we use for, that's what we're going to be using for the images primarily, to specify the regions, because that's just how Allegro does it. Allegro just likes you doing it that way easier, so why not? Let's just do it that way. So let's see here. Now, what we want is the position X position y, and then size x, and then size y. And then that's going to be 0, that's going to be 0, that's going to be, I don't know, let's say 32 for each of these. And that would be a region. And then what we could do here is we do this. We specify the next element in the list. And we want to do this as well. And right here, all we have to do is increase the position. So let's say that it was just a long line of 32 by 32 images, kind of like this. Well, then all we would have to do to specify the next element would be to do 32 there, and then that would reference the next one. But either way, this would be specifying them manually if for some reason you needed to specify the all of your regions manually because you set it up in a weird way. So doing it this way probably isn't going to be that hard. Honestly, with the block slicing thing, that's probably going to be pretty easy for importing the JSON. This will probably be harder for if I want to import the JSON. And then there's another thing which we didn't even get to. So this is just all of the regions. What about slicing? What about image slicing? And let me actually show you an example of this in Unity because that's going to be a lot easier to do. Let's see here. So if I go to the Unity prototype that I made, and I'm going to need this functionality for sure for UI elements. I'm absolutely going to need this functionality for UI elements because if I don't, then the UI is just going to be very, very difficult and annoying to make for no reason. And if I implement this specific thing that I'm waiting on Unity for to show you, then it will make a lot of sense because, you know. Shut up. Okay, so you see this image right here. You see how it has corners, right? Well, where is that? Canvas background, UI border. Okay, so you can see this image right here, right? This image is clearly not the same size as this, correct? So if I actually go into the sprite editor, you can see that there's this corner, and then there's this side, there's this green bounding box line that I have right here. Now, what is the point of that? Well, basically, what it's doing is it's slicing up the images, and it's extending the image to fit an area. So here you have the corner, you have the side, you have another corner, you have a side, you have another corner, side, etc. What you can do is you can just duplicate this side a bunch of times and extend the image this way if you want to. And that's pretty much what's going on in here. And if I go into wireframe mode, I don't know how many times it duplicated it. The answer is not at all, which is actually pretty peculiar. How big is it? 1280 by 720 pixels per unit. Yeah, that doesn't make any sense, but point is it can stretch the image to fit an area by doing this. And I can do the same thing in Allegro. So that's what I'm gonna do. Or at least I'm gonna allow for it. Now, what you need for that is even more tricky. You do need a bounding box. You need the position for sliced UI images. You need sprite sheet. There we go. For slice UI images, you need what do you actually need? You need to, so what we need is the top coordinate, because let's say I actually will go to that image because I have a copy of that image here. So for this image, what we need is the top corner we need a thing to, and that top corner is going to say, oh, all of this is the corner, all of this is an edge and all this is an edge. So we only need 2 coordinates. We need the coordinate for the top corner, and then we need a coordinate for the bottom corner there. So that's pretty much the bottom corner, top corner. So that's pretty much the idea there. Let me actually go back to the JSON guide here and see how I'm going to do this. Books, yeah, alright, cool. So, and, oh, no, you don't use equals, you use something completely different. You use this. There we go. So that's what you use to specify something. And then you also use commas. There you go. So I did not know that. Okay, so that's how you do that. There you go. That should be a proper JSON for the regions. But for this, we'd probably want just spacing or padding. And I have to do that in quotes. So I don't want padding on this image. What I do want is I want to specify the size of the blocks. So let's say size X and then size Y. And then I'm going to want to set these to 32 by 32 because it's my example. And I don't want that, I want that. And then for the offset, we just do this. We just copy this, size X, and then we want to do offset. There we go. And that would be our JSON for block slicing. So what we're probably going to want to do regardless is for regular image we don't have a metadata file, but for this we need a metadata file, and for sliced UI images you need you need a metadata file because you're storing extra information. And then for the regular image, you're doing nothing. And what we do for all the ones that have metadata is we need to specify the type of metadata. So that I can automatically import them easily and the program knows what process to take for importing all of this stuff. So how are we actually going to do that? Well, we're just going to do this. And then we're going to say, oh, it's going to be a sprite sheet, and then that's it. We just need this one parameter in our JSON file, and then that should be good. Because then we could say, oh, sprite sheet or type. I did not mean that. Sprite sheet grid or sprite sheet manual, or we do sliced. And that's pretty much it. So bottom corner, top corner, and then we need, for the sliced UI, that's the same thing. But for this, we have that. Okay, that's good. And then for the JSON for this, we pretty much are just going to need... Also, by the way, this is taking a lot longer because I'm explaining it in video form, but I figured that I should probably get used to explaining all this in video form because, why not? Because I plan on teaching this stuff at some point, so, you know, I thought it would be a good idea to explain my thought process to you guys before I go into the the insanity of coding this, because it's going to be very annoying and difficult, and it's going to take a few streams to do. For the sliced UI images, you need a metadata file and then a bottom and top corner. So pretty much we just need this. And then we need top. And that's it. That is all that we need for the sliced UI. And there we go. That is all of the metadata information that we need to store for the whole image process. That is the entire image process explained in a very down-to-earth way. And let me actually, yeah, I've been live for 35 minutes so far, and I haven't written a single line of code. So that speaks to you of the complexity of making this project work, because oh my gosh, it is a lot. It's a lot of complexity, and this is just scraping the surface. This isn't even that hard. This is not, yeah, this is pretty easy compared to some of the other stuff I'm gonna have to do eventually. Okay, so we have our JSON. Now we need to figure out how to read it. Well, rather, we should make sure that we can do this correctly. So what I want to do, so you see how in the image atlas right now, I want to just get this working for image atlas. We'll make sliced images later, because sliced images are going to be hard to make in the engine. But in here, we're creating this regularly, and in here, you know, we're creating this outside of a scope of anything. What I'd prefer is have the asset database, which if I go into this class, you can see this is a very complex class already, but all the functions are necessary, trust me. If I actually go to an implementation, and you can see that there's this massive file right here, huge file, that does all of the file management stuff for the game currently. Now what I want to do is I want to automatically make an image. So let's say, and here's how the asset database works currently. So we specify a root directory, and then we just do this. So we have bear.png. Bear.png is a thing that exists in the root directory. So we start in here, in this root directory, and then we go, okay, what are we doing next? We go to metadata. Okay, that's a metadata file. Scan that into the database. Let's go into textures. Oh, there are two more folders. Let's go to entities. Okay, add this to the database, add this to the database, and it saves all of the paths of these images on disk so that we can access them later. And we're basically shortening the path to only the file name so that we can move around and reorganize the whole database if we want to, and it wouldn't affect anything in the code. And that's very helpful, as long as the names are different, because if you have two bear.png.meta files, the game will get angry at you. And I can demonstrate that by making two of them very quickly. Let me actually go here. So if I have bear.png and I copy it and I throw it into here, then the game will get angry at me when I run it, because they're going to be two of the same file. There's no way to distinguish between them. Yep, there's a duplicate file in the file system, path, and that gives you the exact path of the duplicate file. Duplicate file names will not get added to the asset database. Please rename this file. And that's pretty much the entire crux of the system working. So yeah, that's pretty much the whole deal with that. Now, what we want to do is we want to take this file alias and we want to directly convert it into either an image atlas or just a regular image or a sliced image, because those are all going to be different classes and they're going to be managed differently. So what I'm thinking about doing is I'm going to get image type, or no, so I need to get file type, And there's going to be different types of files. So let me actually think about this. I think what I need to do is I need to make an enum for the file type first. So let me close up all of the unnecessary folders that I have open. And general, we don't need any of that. Okay, engine circ asset database. We have all this. We need to add a new item, which is going to be a header file, because we're going to need to do an enum. So you have file type .h, and then we're going to do namespace pixel engine as usual. And the reason why we're making an enum is so that we can distinguish between all of the different file types. We can just say, oh, what is the file type of bear.png? Oh, it's an image atlas. Import it as an image atlas, and then that's why we're doing this. So let me actually do this C++ enum, because I don't remember how to do this.
Hey, what's up, guys? My name is Zen.
The Cherno has helped me out so much.
States
I heavily recommend
I'll
it.
get an error because it's for an enum that can't. It's fine. I just need to change the log. This level isn't really a namespace, so you can't use.
Okay, so you just do that enum. File type. Okay, so we need to do, what am I gonna do? Well, how am I gonna do this? So, I need image, image sheet, sliced image, metadata, and what are the other file types? Sound file, text file, save file, and I think that's going to be it for all the file types that we're going to need for right now. And of course we can come back and do this later, but for right now this works. So, Lua script, because at some point I might actually add Lua functionality to this game with scripting. Probably not, but you know, never count it out, I guess. So here we go. We've got file type, and now what we want to do is we want to close that, and we want to close both of those, and we want to go to asset database.cpp. Or no, H. We need to do this in the declaration. So here we're getting file path from alias. What we want to do is we want to string, or no, file type, which we don't have that imported. File type.h. There we go. So we need file type, get file type from alias. And another thing that I want to do with the metadata is that we need to do file type, or no, we need to do image type, and then we need to do file type. Do something. I don't know what file, image. Something like that. So here we're going to get the file type from an alias, and I just need to make a function that figures this out for us. And for the alias, we just need a string. And we don't need to get a slash type. All we need to just do is return the file type. So here I can create a declaration for this. There we go. Implementation created. I don't need that because I'm inside of Pixel Engine up here. so I don't need that namespace thing. Okay, get file type from alias. What are we gonna do for this? So first of all, for image, we're just going to do PNG. And I think, let's see. So we need to, do we have a function for getting the thing? Is file readable loop wrapper, convert path slashes, get alias from string. Nope, okay. So, string get extension from string get file extension from string file path. And since this is always a period, it's going to be very easy to do this. We're also going to want to create a method implementation for this. So in here, all we need to do is loop through all the characters, do something like this. Size t file path dot size. Yep, if it equals period. And then we're not going to do that. We're going to do, if file path I is equal to period, we want to make a substring. And I forget how you make a substring with this. Oh, you can just do erase. I plus 1. There we go. So it's going to erase from 0 to the current, because everything before the period is not important. I minus 1. Because we want to include the period in the file path. Return file path. Let's actually test if that works. Out, we need to say alias. So in our application, let's actually try this out. So let me actually, so we have this bear for testing. Let me actually throw all this in a comment down here, because we don't need any of this code anymore, pretty much. At least for right now. So now what we need to do is we need to test that function. So database dot get file type from alias. And of course we're not going to actually get the file type from alias yet. We're just testing this internal function. I think I made a mistake. Signed, unsigned mismatch. Must return a value. File type. Let me actually do null as the null, or no. Here. Null. And then unknown. So the null and unknown, this is pretty much gonna say, oh, there's an error. This is gonna say we don't know what file that is. So there's a difference between there's an error and we don't know what file that is. So I've indicated that. No. There we go. Alright. G unrecognized. Okay. So r.png. That's wrong. So in here, maybe we do not -1. Oh wait, it's probably inclusive. So here, Let's check the erase function. Nah, you know what? I think it's probably just inclusive. Let's just do that. There we go, .png. Easy. So this just gets the file extension from any file path, including just a file alias. So here, we're getting bear.png and we're detecting that it is a PNG. So, if, or no, let's do a case. Switch case. C++, because I don't know how to do this in C++. Switch case statement, switch expression, case, da 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 da. Good, alright. That's same as usual, pretty much. Good to know. Okay, so for the switch, we're going to do get file extension from alias, and then we're going to do that, and then we're going to do default return file type, not null, but unknown. Must have an integral or enum type. I don't know what that means. Not C string. Is that still not right? Okay. Maybe if we put this inside a variable. Nope. Weird. Expression. Char. So you can do a char. You can do numbers. How do you do C string switch case? Case. Type. Oh, so if there's no extension, we just have none. It doesn't have a file type. So that works. But like, for some reason it just doesn't want us to do this. Because here you can, this is so weird. Sure, accept all cookies, but the point is that it's like, if you mean how to write something similar to this, switch string da 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 da, then a canonical solution is C is to do an else ladder. That sucks. That's so dumb. Is there a way to do this with C++? Just use... Oh, you've got to be kidding me. Ah, screw you, C++. Screw you. Because this would have been way cleaner. Now I have to do something stupid. Amazing. So if it's that, we do file type none. If file x is equal to .png, we return file type. Image. Image sheet, sliced image. Yeah, so those are separate file types, but they store a PNG. So what we need to do in here is we need to actually make that. And somehow what we need to do is read the metadata. Or first of all, check if metadata exists. which is not hard. So you want to do, I think I already have a function for this. So if we do get metadata file from alias, alias is equal to that dot cease. Is that right? Too few arguments. Sure, I'll just do that for slash. Oh wait, I have to do a char. There we go. So if it's equal to empty, then that means that there isn't a metadata file, which means we return file type image. Otherwise, if we wait. So we need to do const char pointer meta extension, or no, meta path. Get metadata from alias to C string space meta path. Pointer is dangling because it points at a temporary. Oh, that's annoying. What if we just do string for both of these? So I don't think it matters because if we, yeah, is unscoped. Enum class over enum. I forgot about this stupid thing. Class. I forgot how I did this in previous things. Oh, that's annoying. That's so annoying. How do I fix this? I remember this was in my previous project. Let me just open that up because I know I have an enum in here somewhere where I know how to do this. Sure, whatever. Just give me the thing. General functions, I think it's in constants. No, it's in render objects. Render type. Enum class, render type. Okay, and that just worked. Enum class file type, and then it's just this. Yeah, so then what's the problem? It's not a type name. Well, then how was I doing it in I mean, I was doing it as a database. Well, it works. It doesn't work here. Okay, well, that's weird. I don't know why IntelliSense is being dumb AF right now. Nope, I'm just gonna ignore that. You know what? I don't care. If metadata path equals that, then we're good. If. And then we can use the metadata path later to actually get the metadata, because we do need to parse that at some point. Man, I'm already getting really tired from explaining all of this. Because usually what I do with all of this development stuff is that I don't do this live, so me having to explain all this is like a little bit daunting because it's very difficult to explain, but you know, I'm getting there. Return file type image. Okay. So null, unknown none, image, sliced image, metadata. What we need to do for metadata is we need to do we can do just the function for that. Bool is file readable. Bool is bool is file metadata. There we go. Now we create a method implementation. Alright, awesome. And then for the alias, we need to do pretty much the same thing as, or wait, you know what? Since it's the same thing, I think I can actually do without that function. Because it's an extension on top of an extension, so I can do get file extension from string. Because files can have multiple extensions, so we need to get the extension number. And we're just gonna set that to 0 by default. Is equal to 0 by default, and then inside of here we want to do this because we're going to need this. Alright, so we need to do and next number is equal to 0. So, if x number is equal to 0, we do that. And then else x number minus minus. I think that should work. Let's see here. Okay, so I'm going to comment this out for a little bit, just so I can test this. Just so I can test that this metadata working gets, or this metadata getting works. There we go. And then out this. And then we need to get the first one instead of the 0th. Meta. G unrecognized. What is this? Redefinition of argument? How about I just do that? Must return a value. Bear.png.meta. Okay, weird. That's not correct at all. What if I hold on. So I'm getting number 1. What if I get number 0? It still gives me bear.png.meta, which is wrong. Is less than or equal to 0. Oh, wait. Wait, I'm doing this wrong. There we go. And we do this. But we need to encapsulate this whole thing right here. .png.meta, and then we do 1. Where is that? Is it right here? Okay, so we do 1. And then we just get .meta. Awesome. So, great. That was not super hard. What happens if I, let me actually just do this. What happens if I remove the meta from here? You just get the full string. If this is equal to alias, and then we want to return file type metadata. Or wait, no. Does not equal alias. And for application, we want to out this. Alright, so 0. Crap. Bear.png 0. Oh yeah, because I didn't do .meta. Dumb, stupid. There we go. C.meta. Which is 6, which is metadata. Amazing. Woo. So that works. So if we do this, then it's metadata. Otherwise, we can get extension from string alias. File extension is that. File type.none. Check if metadata exists. Meta path equals to that. File type image. Okay. Else, we're going to have a whole thing going on where we check the file type for. We need to check it for if it's sliced. Well, yeah, we need to check if it's an image sheet or it's a sliced image. And that shouldn't be that hard. Let me actually take a quick stream break. Yeah. I don't know. I'm just gonna use the restroom really quick. Okay, so a few things have become apparent. I am probably going to need to stop just due to the fact that I have lunch and I have work today, so I guess I'll see how this goes later. But yeah, I think that's gonna be it for me. I think it would be easier to get the metadata reading working solo. But yeah, we'll see what the whole deal is. Probably gonna work on this later tonight, possibly. Not really sure, but yeah, I need to